Welcome to Inside Out of Ella. I'm here with Dr. George Rebello. So usually just George, but George, you did your PhD in?
So I worked on the Human Genome Project at
Yes.
the University College London way back when. And in fact, I was one of the very large number of authors who worked on various parts of the genome at the time. And it was super exciting because it was an opportunity for us to say, here is a project where we're going to make a difference to the world.
Absolutely.
And that was really all everyone thought about, was that we do this thing, we're going to actually change the way medicine and a whole heap of other sciences are being carried out. And it was a very exciting time.
I must say, your name, I've read it in a textbook before, so I don't want to give anyone's age away. But I remember when I met you, George, I was like, are you Dr. George Rebello? And I know a lot of people react like that. So you've got a very diverse, you could have gone into the human genome, you could have gone into such diverse range. Both of myself and yourselves decided on human genomes.
Yes.
And I mean, like, both of us know we could have made a fortune out of, taking seeds out of grapes and selling it to people or whatever.
Breeding foster horses.
Yes, you did. But we decided humans, and there's a big empath and wanting to really change people's lives. Now, when I met you, I remember feeling and resonating with your passion. And not a passion to change even, yes, the industry, but even just one individual. And every time we meet at the lab, it's usually we talk about individuals, and we usually talk about there's this little girl. And what I love about it is we never say names. It's always a barcode number, but we see the human. And I want to just commend you on that. You always see the human aspect. And although you work with data day to day, you have a big human factor in it. So, George, you do pharmacogenomics. So, for those of you who doesn't know, pharmacogenomics is basically how your genetics influences how you metabolize drugs.
Correct.
But what is so wonderful, and I've told you this before, I actually stopped doing pharmacogenomics because I felt that we need more data and more brain energy in it. And then I came across you, and you're doing drug gene. So not only how the gene and the drug influences, but how the drugs influence with one another. And you also look at kidney function, liver function. George, I want to stand still and ask, just to explain what you're doing, well, how I understand it, but I want to ask, why pharmacogenomics?
So interestingly, I haven't only ever worked on pharmacogenomics. I think I did my first project on pharmacogenomics in 2008, which to me is not a long time ago, but I guess to some people is quite a long time ago. But prior to that, I worked in diagnostic labs. So if you ask me why I look for the person, it's because I started my career working on babies, on the genetics of babies, at a time when we couldn't do much to help them except identify what was wrong with them. And with the Human Genome Project and everything that came after that, we were in a position to say, I can see what's wrong and I can do something about it. And pharmacogenomics is sort of the extension of that, because everybody takes drugs.
Yes.
Everybody in the course of their life at some stage, even if it's something for a toothache, you will take a drug. And more of those drugs now have a genetic profile that's been well developed, well understood, and is clinically relevant. And if we look at those things, we can tell you things about your drugs, the person, not the average. Drugs are registered on an average. So when you screen 1,000 people, and if on average they do okay, you can register the drug. But actually each single person will be different. And that's where the passion for me is. We don't do average medicine. We don't do average genetics. We do that person, that one patient who has a life story, who has all the problems that they've brought with it that we don't see. And you were right to comment that I don't do names. And that's just a habit of working in a lab for many years. But it also makes it easier, because I don't go Mrs. Smith by mistake. I always go sample 63 or 295. And people around me in the lab sometimes go, don't you mean Mrs. Smith? And I'm going, no, I mean sample 295. Because it just keeps it cleaner. It doesn't mean I care less about Mrs. Smith.
No.
It's just...
It's a beautiful
it's
balance.
An easier way, yeah. It's an easier way of sort of respecting the patient's anonymity as well as their uniqueness, the singular nature of their genes and the way they interact with everything.
George, now you mentioned something so important. If you say pharmacogenomics, a lot of the time a client would think, okay, but I'm not on medication, or I'm only on one drug, or I'm not on chronic medication. But this applies to painkillers, antibiotics, but that is one conversation. One thing I want to ask you on is oncology. I think cancer is a very emotional thing. We report back on cancer risks as well and how to prevent it. And every time before I open a report and I discuss it with the client, I will always have a pause. I'll tell them, I'm going to open the cancer report now. Are you comfortable? Can I discuss this with you? Do you want to discuss this? Partly, I think it is Hollywood, but also it is a very horrible diagnosis. We are in a world where the stats are helping people work through it, but even if you work through it, it's not a pretty path. And what makes me, I can even hear my voice, what makes me so like upset is that people are prescribed medication before testing if it would actually work for them, in a case where it literally is life or death.
Yeah.
Can you tell me more on that?
So I think you're right. Oncology, I think generally there's so much that pharmacogenomics can do, but in oncology the consequences can be so dire.
Yes.
So you're giving a patient chemotherapy. The object of chemotherapy, generally speaking, is to almost kill the patient. And in doing so, hopefully you kill the cancer. So you set out to actually harm the patient, to damage them as much as you can without actually killing them. Now, if I'm just a little bit too sensitive to that medication, you're going to go beyond the almost. And we've got quite a few good markers for that now. So it's not just, there's one thing we can tell you about that may be interesting and sometimes doesn't work. No, there are now quite a few good markers for quite a few of the important medications. And there are new markers coming out that will tell us about the new classes of drugs, including the biologicals, which are going to become more important and they're the ones that are going to change cancer. Yes. This is where we as geneticists are one day going to be able to say, I've profiled your cancer and I can tell you exactly how we can cure it. Not stop it, cure it. And we're not there, or at least we're not largely not there, we are starting to be there. And that makes this area more important. And if we can tell the patient beforehand, because we've had this discussion before, we've had this discussion with lay people who are saying, who would expose themselves to the risk of chemotherapy, to the consequences, without a test, a simple test that will tell me, this is going to make me sick, it's meant to make me sick, or this is going to make me so sick that I could die, right? And that difference is, it's going to be horrible. I'm sorry to say it's going to be horrible, but it doesn't have to be deadly. If we can actually catch those few patients who have those changes in their genes that make them susceptible, we can actually change the outcomes for them. So.
I think the reason also why I mentioned and saying Hollywood shaped cancer in a very bad form is you never start a movie where the patient has cancer and it goes, they did a pharmacogenomics test and they got the exact correct medication and they lived and they were happy and healthy. Unfortunately, it's a drama and it's sad and it's going to make you cry. And I think people are so skeptical and sensitive, even when we report back, and I respect that, they would rather not know if they've got the risk, or they would rather not know. And it's so important to know it's your choice, but you can know how your body metabolizes different oncology medication. Another thing I want to touch on is antidepressants. So we work with children, we work with adults, we work with elders, and we do DNA tests, and we can see if they got the genetic risk for different neurodegenerative disorders. And also people open up. So most of the time, so I've got a background in psychology as well. Interestingly enough, my mom operates in trauma psychology. So on a day, she works with clients on how to get trauma out of their body and how trauma stays with you if you don't treat it. And I think depression, it's very interesting. If you look at the DSM, there's a major depressive disorder where you are diagnosed with imbalances of hormones in your brain. But as a human being going through life, you almost get we expect 4 to 6 depressive episodes in your life, What this means is you're maybe going through a biological change. Usually for men, it's between 25 and 35. They start to struggle with anxiety because there's a serotonin drop. Hormones are changing. For females, usually you know about postnatal, postpartum depression. There's like hormone changes or trauma. Someone dies, something traumatic happens to you. We expect you are going to have a depressive episode. So now we're working on environmental factors for depressive episodes, and we're also working on someone has the risk for having major depressive disorders. On the market, I think there's more than 20 different antidepressants to prescribe. I want to have your number. On an average, I've got a number. How many antidepressants can a person metabolize? Let's say I do the test. We test on 20 different antidepressants. More or less, how many would work with me, would accommodate with my DNA, would accommodate, but we might need to change the dosage, and how many would cause actually other effects?
So I think, I'm kind of hoping I understand the question properly. I think there are sort of 3 subclasses of sort of metabolic pathways for these drugs. And they don't quite fall evenly. You can't divide it into 3 numbers, like 3 sevens or 21. It's the majority of them are processed on one pathway, and then there are lesser numbers processed by others. The advantage of this is, of course, when we do the pharmacogenomics, if you are imbalanced on the one pathway, we can say those drugs, that class of subclass of drugs, in other words, the antidepressants that are processed by, let's say, CYP2D6. If you're a CYP2D6 not suitable, then we can look for the other ones processed by COMT or processed by ADRA2A or any other genes that we know process these drugs, because they don't all, fortunately, run normally through exactly the same pathways. Some of them do. Some of them can be incredibly difficult. Some of the stimulants can be very hard to accommodate if you have COMT mutations, for example. And if you are very, very poor metabolizer at COMT, almost all the stimulants become not good for you. And we would then have to find the ones where we're being subtle about how well you're processing it, or how well the gene regulates the processing. So it's thirds, but it's not thirds in terms of numbers.
Yes. Yeah. So what I meant by that is what I see happens is, and thank you for explaining it so well, the client would jump onto different antidepressants, but they would stay in the same pathway.
Exactly. Yeah.
So
they won't work. None of them will work.
None of them would work.
Yeah.
So now you are going home thinking antidepressants don't work. That causes a whole psychology on its own, where it's just the pathway. So I think we're entering a world, and I hope that we're entering a world where we're working multifactorial. We're looking at nutrigenomics, how your body metabolizes nutrition. We're looking at pharmacogenomics, because there will be a time that you will take a medication, like you mentioned. If it is pain medication, antibiotics, if you're going for a procedure and they need to give you medication. Anesthetics. My question to you would be, when would be the correct time to take a pharmacogenomic test?
Okay, so it's almost unfair to ask a geneticist that. But the truth is, the good news is, since your genes, generally speaking, don't change, your predispositions, generally speaking, don't change, except if you end up having liver function flaws and things like that later. So you could test every newborn baby. We could bank their typings, because the typings aren't going to change. And any medication in the course of their life that they have to take, the answer could be given straight away. And I think we are going that way. At least the rest of the world is going that way. We, as we often not surprised to discover, lay a little bit behind. But we will go that way too. It'll probably become not permissible to practice medicine on somebody without knowing their genetic profile.
I'm really looking forward.
Yeah, I think so, because silly things would be avoided. Like giving a drug for months and wondering why the patient doesn't get better. Well, they're not metabolizing it. They are passing it out in their urine, probably unchanged. Yes. And you prescribing the med and wondering why they don't get better. And that's not fair. I mean, a patient who has an adverse drug reaction, that's terrible. But generally speaking, I go back to my doctor with a rash, my doctor changes the drug, right? So it's almost self-correcting. But you give me a med for years and years for depression, and you think, oh, this guy just doesn't get better. Well, sure, the drug you're giving is not active in his body.
And I think I've cried with clients where we've given them feedback that the medication they were on, they weren't metabolizing the medication, and they started crying. Because I think, in essence, they sometimes even feel it's their fault. And they sometimes even feel that there's something wrong with them, which it's not the case.
So genetics has a way of doing this, right? Because we take our genetics so personally.
Yes.
If you tell someone they've got a defective gene, they really do often feel as though it's their fault. So what did I do wrong? Or worse, what did my mom do wrong? That's even more sad, really. But the fact is, we do take it very personally, and it's not actually, it's not possible. I didn't make my genetic profile, and I can't, by and large, change my genetic profile. But knowing it is what answers questions. And for those patients who've been on drugs for a long time that haven't been working, the focus should rather be, we now know. We now know what not to take. We now know what to avoid. And by and large, we know what to put in its place that is going to work. And that's good news. That's not bad news, which just sort of circles us right back to where we started. Why do I want to do pharmacogenomics? Because it can work in most people. 99% of people are carrying markers that will actually change the metabolism of some common drug. So at some stage in your life, even with a limited set that we're doing now, we will be able to help you. We'll be able to say, avoid this drug, take that one instead. That's cool. I mean, that's cool because that makes a difference.
I love how you always talk with passion in your eyes. Thank you, George.
No, it's absolutely my pleasure.
It was wonderful having you.
Thank you.